Hello, so welcome to 2015 Paper 1, Question 5. Again, as always, just to say to you, you're better off pausing this now and just tackling the question, and even see come up with a strategy and continue on. So, assume you're back if you have paused. Now, this question is to do with functions and algebra. So, we're dealing with function notation. So, I can tell here that, again, if you see f of x, you can call that y equals whatever. It's a quadratic, because it has a power of, the highest power is power of 2 on the x. And they're saying, the diagram here shows the graph of this particular quadratic. That's a negative x squared, so it looks like a mountain. Okay, a positive x squared looks like a valley, the other way. You see it's between 0 and 5 on the x-axis, so 0, 1, 2, 3, 4, 5. Now the function g, okay, is given here, g of x equals x plus 3. Now this is, again you can say y equals x plus 3. This is linear because it has a power of 1 on the x, it's the greatest power. I can tell from this now that this particular line, if it's written in that form, it's written in the form y equals mx plus c. Now, excuse my, this thing is not the best thing for writing. Mx plus c. So if you see they're compared, in front of the x, now it's written as 1y equals everything else. The number in front of the 1, so the x is 1. So the slope there of that particular line is 1. The number at the end is 3. That represents the c, and that's where it crosses the y-axis. Not the x-axis, the y-axis, so this axis here. Now, if something's a slope of 1, it means it goes up 1 for every one it goes across. So if it goes up, now it crosses through here, okay, and it goes up 1 for every one it goes across. So it'll join through this point here and this point here, etc. So I'll try my best to draw a straight line. That was actually pretty good. Okay, so the points A, 1k, so we know that they're looking for the point where x is 1, so that's here. So basically, I now know that's what they're looking for. So I have the answer. K is 4. But let's read through it and see if there's another way of doing it. The points A, so 1k, and B are the points of intersection of f and g. So this actually intersects twice. So this is your g function. This is your f function. Now intersects at those 2 points. So it says find the coordinates of A and of B. Now, the coordinates of B there would be what? 3 on the x, 6 on the y. Okay, so we're going to go to the actual answer here. Now, that's one way of doing it here. Actually, that's the way I did it when I first looked at it here. What we could do is, in the way I have here in this particular side, is where I put both functions equal to each other. Okay, so the function x plus 3 equals fx minus x squared. That will tell you where the two functions are the same, which is at their points of intersection. I then bring them everything across one side, and I've actually brought the x squared across this side and the 5x across. So the negative x squared become positive going across the equal. The positive 5x has become negative going across the equal. And you end up the minus 5x adding to the x, leaving minus 4x. The 3, there's no other number to affect that, so it stays as 3. So that's the quadratic equation. Okay, I can go ahead and solve it. I'm solving that using the fast method. So basically I'm looking for what numbers will multiply to give plus 3, okay, and add to give negative 4. Okay, so the only ones are now 3 by 1 would multiply to give 3, but also minus 3 times minus 1 would add to give plus 3, or multiply to give plus 3. Now, which of those two numbers would add to give negative 4? Well, obviously it's those two, and they're my two factors. So I've written them in here. Now, you could have used the minus b formula, but that would have made things harder in the sense that you would have had to spend more time. So I've got here both factors. If two things multiply together give 0, the assumption is that one of them is 0. Now if one is 0, both could be 0. So that's why I'm able to make the statement. X minus 3 is equal to 0, or, should put that in there, x minus 1 equals 0. Now solving both simple equations, bring the 3 across, the negative 3 becomes positive going across the equal. The negative 1 becomes positive going across the equal. So that I found my two points of intersection are at x is equal to 1 and x is equal to 3. Now, so just to find my y values, I take my g function. Okay, remember g of x means same thing as y. So if I know x, I can calculate y. At the moment there's 2 unknowns, but I know that x is 3, so put it in, and I get out the answer of, was it 6 here? Okay. The other one is when x is 1, so put 1 in instead of x and calculate my y. Comes out as being 4. So does that correspond with my first answer? 1, 4, and 3, 6. It does. Okay. So 2 methods of doing it, both equally valid. That's part A. Move on now to part B. It's worth 10 marks. So the point 0, 0, which is the origin, and the point 5, 0 are on the graph of F. Draw the quadrilateral OCBA on the diagram above. Now, I may have done the answer here. I have, okay. So I've drawn it there on the diagram. That's A and B. And there's the origin. And there's my point C, which is 5, 0. So that shape in between, I'm kind of indicating there, that's my quadrilateral. Part 2 then, find the area of the quadrilateral OCBA. Now, one way to do this is to break it up into separate shapes. Now, the way I've done it here is the area of the full shape equals the area of triangle ODA. Okay, that's that triangle just in there. Okay, that's that. So next one, area of DEBA. So DEBA. Now, that's a rectangle and a triangle. Okay, so that's there. And the last thing is the area of the triangle ECB. ECB. So that represents the full shape there. Now, I've put in the formulas there. So this actually is, what's going on here? 4 plus 6. Now, I could have broken that into 2 things here. As in like a triangle there and a rectangle. I haven't done that here. I've gotten the area of that shape. Now, so we'll pause for a second. Okay, I just forgotten actually how I was getting this formula. That's actually the area of a trapezium formula, which is probably not the way I would approach it. But when I was making up the notes, I was taking it from the Martin scheme. So that's the area formula I'm talking about here. It's in the maths tables. And that's the area of parallelogram on top, trapezium, circle, whatever. And if you look at it, it's a half times A plus B times H. Is another way of expressing that, which would look more like what I've done here. So it's a half times. And that's the 4 units on top, the 6 units on the bottom, and then the difference in the height in the middle is times 2. Okay. Now you could have done that by getting half base by height of this triangle, and then 2 times 4 for the rectangle. Okay. Equally valid way of doing it. And no matter how you look at it, when I put that whole thing in the calculator or do it by just 3 different sub parts, I get 18 as the answer, and that's unit squared. If I'd actually read the thing down, I've actually explained where I got that area of trapezium formula. And okay, that's part B, part 2. Okay, that's question 5. So part A, and that must be worth 15 marks. Okay, so that's a lot of marks. And that's question 5. Okay, thanks very much.